Thank you so much for having me today. I do indeed have a little bit different background. It's mostly in mathematics and science and not so much in literary. I studied Shakespeare in high school, never appreciated it. Later in life, I became interested in him again. And at some point, I started to try and ask myself, who is this guy? I mean, who wrote this? Who's writing this stuff? So I started to research his biography, and probably we've all been there. And his biography is wanting. I mean, there seems to be almost nothing known about his life. He got married, he had kids, and he showed up in London one day, and that's about the extent of it. So this sounded a little light to me. So I did find an article by Mark Twain that was written years ago called "Is Shakespeare Dead?" Now, if you look at this at Wikipedia, they say Twain is making a joke, and Twain is indeed a humorist, but he's very, very serious here. When he was sailing the Mississippi on his riverboat, he would read Shakespeare to the captain would read Shakespeare to him. And he noticed that Shakespeare uses a lot of legal terminology. He used it so well that he believes he had a very, some kind of an academic legal background. And that you couldn't convince anybody of your background unless you could use the terminology. And he also understood the biography of Shakespeare was very wanting, and you have to conjecture everything. So you have to conjecture, when he came to London, he worked for a law firm for a few years. He worked as a legal apprentice or something. So you have to conjecture his entire background. That was really disturbing to him. Like, there's nothing at all known of his education. And the thing that really grabbed Twain is that if you've ever heard of Hannibal Missourius, because Mark Twain, who wrote under the pseudonym Mark Twain, or it's really Samuel Clemens, he put Hannibal Missouri on the map. That's why you've heard of it. But when Shakespeare dies in 1616, no one in Stratford seemed to have noticed. So this was a big red flag for Twain. So I asked myself, has anyone tried to do analytics on this or tried to do any kind of text mining, anything? And it turned out someone has. So back in 2007, there was a team at Dartmouth who took a look at the Shakespeare authorship question. And they note that almost all scholars agree that the man from Stratford is the author. However, just as well, they decided to do some analytic comparisons between the works and they chose three of the top authorship candidates. One was Marlowe, the other was Francis Bacon, and the third was Edward de Vere. They used three statistical techniques. One was character distributions, the second word length analysis, and the third was the ratio of unique words, which is an interesting dynamic. Like, how often does a word that only appears once in your corpus, what's the frequency of that? So that's something like a tell. It's not something you'd be conscious of when you're writing. So it's kind of a tell as to the author. So what they found was that these statistical tests, like the character distribution, were ruling out Marlowe and ruling out Bacon. And when they came to the third test, which was the ratio of unique words, Bacon and Marlowe were so different from Shakespeare and with very tight variances on those, so they could rule them out. So the conclusion was a hypothesis that they were the same author Shakespeare was rejected. However, when they looked at the word length ratios of Edward de Vere, he was indistinguishable for Shakespeare. So it's a very powerful statement statistically. The hypothesis that de Vere and Shakespeare are the same writer could not be rejected based on that metric of the word length analysis. So typically in data science, anything below a 0.05, your p-value, which gives you a percentage or a probability, anything that low is usually rejected. De Vere was up near 40%. So that's very powerful statistically, saying the two were indistinguishable. They can't tell them apart statistically. The last test they did was the one with the ratio of unique words, and they got a shock, and they write that the surprise came when we used our unique grade ratio to look at Edward de Vere's work, and he turned out to be almost a dead-on match. De Vere has a ratio of 0.31, and Shakespeare has a ratio of 0.30. So the other two candidates were basically ruled out, but this one was almost a dead-on match. And it says that completely validated the result they got from the word length distribution. And their conclusion was perhaps de Vere was Shakespeare, and that the Oxfordian authorship proposition had merit. So this was so interesting to me that I decided, is there a way for me to follow up? So I used a statistical platform called R, which was developed at Bell Labs a long time ago as S, and it morphed into a really powerful platform that used by data science today called R. And it can do all kinds of statistical analysis. The motto in the R community is R can do it. But so I decided to take a corpus of poems, because De Vere doesn't have any plays that are extant, but a corpus of his poems, and compare them to some other poetry from writers at the time, like Ben Jonson, John Fletcher, Marlowe, etc. And to do the analysis, I have to have about a similar amount of volume of material. So De Vere has less than 4,000 words, about 23 poems that are attributed to him that he published during his lifetime. So I split some of the larger poetry into pieces. So the sonnets I broke into 3 groups. The poem Lucrece, which became Rape of Lucretia later, is split into 3 groups. And Venus Adonis I split into 2 groups just to get some kind of a comparison. So what this does now is create what's called a term document matrix. So it goes through the poems that are amalgamated for each author. So the first one here would be a specific author or corpus of his work. And you can see the word oblate here appears once, and the word abide appears twice. The word abjure appears once. For the second author, he doesn't use these words at all. They're all 0, but when he gets to the word able, that appears once. So this is like just a little tip of this monstrous iceberg. This matrix is actually 14,000 columns long, because there are 14,000 words in here. So I'm just showing you what the flavor of it is. And in mathematics, this would be called doing a Fourier transform, because you've transformed your data into a frequency space. So I'm looking at the frequency of each word appearing in each document. And this creates kind of a vector in phase space, or a point in space, if you can visualize that for each document, or rather for each corpus of documents for each author. Now, how can you tell them apart? Well, this is sort of the equation you remember in high school, which is based on the hypotenuse theorem, a squared equals b squared plus c squared. Basically, let's say I had 2 documents. The first document has 3 words, 5 plus 5. The second document has 3 words, 5 plus 6. So on the x-axis, I have the word 5. And on the y-axis, I have the word plus, and on the z-axis, I have the word 6. The first document has 2 occurrences of the word 5 and 1 of the word plus. So he would have a point here on the plane, the xy plane. But then the second document has 5 plus 6. So he's 1 on each plane, and he comes out and jumps out in the z space, and you see a point here. So I have now 2 points in my space, and to find the distance between those points, I just take the distance metric that you learned in high school, which is the square root of the differences of the terms. In this case, the metric would be the square root of 2. Now imagine, if you can, if you will, a 14,000 dimensional space. So that's an enormous space that encompasses this corpus of documents and the words in it. But you would still have a point in each space representing each document. And you could still use the same formula, the same metric, except this radical has 14,000 terms in it. So that's just an intractable calculation for a human being. But modern computers can do that calculation very, very quickly. And so what they do is a technique called hierarchical clustering. So this algorithm that I used, so there are 2 methods. You could start out, put each document in its own cluster, and then you merge the clusters together based on their distances, and then you calculate a new set of distances. The other approach is to put everything together and then break them to pieces. I use an algorithm called hclust that does the collaborative hierarchical clustering. So it takes each document in its own cluster, then it finds a pair of clusters that are closest to each other, and it merges them. And then that's got 1 less cluster, and then it goes and does the same calculation again and merges documents together. And what that does is build up a tree that shows interrelationships between documents. So this technique is called unsupervised learning. In machine learning, you have unsupervised learning and supervised learning. So a supervised learning example would be predicting if someone's going to go into the hospital or not. And that would be based on his comorbidities. If he is a drug user, does he drink, use alcohol? Does he have diabetes? Does he have cancer, et cetera, et cetera? What's his age? What's his blood pressure? Things like that would all correlate to his probability of hospitalization. If you have a large enough data set, you can make a prediction for the future for people. That's called supervised, because I have an example that I'm trying to target. In unsupervised learning, you don't know anything about the documents in this case. You're just trying to see what are your interrelationships. So it's a different regime space than the Dartmouth authors were using. And the end result of this is called a cluster dendrogram. So what it does is it looks for things that cluster close to one another. So one thing you can see right away is that the sonnets all clustered together, which is really good because I broke them into pieces and I was expecting that to happen. So that's a good test that the technique is kind of working, because I've kind of split everything into pieces. That's what physicists do. They smash things together and look at the pieces coming out. And so this is what I've done to poetry. So I've done violence to the poetry, and I've reassembled it all back together again, but still it's giving you a reasonable result. I mean, I've jumped through a lot of mathematical hoops here, but that looks good. And then Venus and Adonis, those two clustered together, that looked good. And then I threw in two guys for fun, which was Ogden Nash and Walt Whitman, who are Americans, and they're from an entirely different era, different century, and they clustered together. So those are the things I was hoping to see. That's what I expected, and that was good. Now, this one is interesting. Francis Beaumont and Ben Jonson clustered together. I didn't know this. I had to look this up, but it turns out that Francis Beaumont was Ben Jonson's student. So this was cool. It found something I didn't know. So I was kind of happy that it was giving me reasonable results, considering all the mathematics hoops I jumped through here. Now, look at this. Earl of Oxford clusters directly next to the first part of Rape of Lucretia and then adjacent to Venus Adonis, this whole piece here. When I saw that, I was stunned, because I know, as many of you know, that the Earl of Oxford stops writing just as Shakespeare starts writing in 1593. So this is all the earmarks of an author who stopped writing under one name and starts writing under a pseudonym. And it's completely consistent with the theory that the first speaker talked about, that someone's writing under a pseudonym. So I was stunned when I saw this. I notice I haven't used any kind of literary historical thing. I'm just looking at text mining analytics here, but it's backing up what the Dartmouth group found, that you can't tell these people, these writers apart, that his early works that Oxford wrote are just clustering right next to the earliest poems of Shakespeare. So this was very, very exciting and provocative. And as interesting as this is, it doesn't prove that he's the author. It doesn't prove that Oxford wrote the works of Shakespeare, but it is a piece to the puzzle. And the way you can assemble the puzzle pieces here is a technique called Bayesian inference, based on Bayes' theorem, who was a Presbyterian minister, and he came up with this mathematical idea. And basically this formula, all it's saying is the probability of a hypothesis, given that an event E occurs, is related to the original probability of that hypothesis, with adjusted by a likelihood ratio. And that likelihood ratio is the probability of the event happening, if the hypothesis is true, divided by the probability of the event. I'll give you some examples of this. I know it sounds confusing. It's confusing to me, but it works. And the basic idea here is that you can update your belief in something. So this is different than the frequentist approach that people use, like flip the quarter 1,000 times and count. Okay, it's 502 times, so it's about 50-50. This lets you update things and do it in an iterative way. And this is kind of very, very popular technique today. It's used in a lot of fields. So let's give a quick example of this. So what's the probability that a card is a king if you're drawing a card from a deck, given that a face card is drawn? So we want to calculate that using Bayes' theorem. So the prior probability of drawing a king just randomly from the deck would be 1 in 13, because there's only 13 different kinds of cards in the deck. So the next factor we need is the probability of a face card if it's a king. Well, if it's a king, it's absolutely going to be a face card. So that probability is 100% or 1. Since there are 3 face cards in each suit, Jack, King, and Queen, the raw probability of the event of getting the face card is just going to be 3 over 13, because there's 3 face cards, 13 possible cards. So combine these together by just multiplying 1 times that. This term, 3 over 13, goes in the denominator, so it flips. And you get your likelihood ratios now 13 over 3. Multiply 13 over 3 by 1 over 13. That's our original probability of getting the king, and we get 1/3. So the probability of the a king being drawn if I know that a face card was drawn. That's our event, and the event could be a new piece of information. In this case, the new information is I drew a face card is 1/3, and we know that's correct. If you got a face card, there's only 3 possibilities: king, queen, jack. So it's going to be 1/3. So this seemed like a complicated way to get a simple result, but you can see how it works and how it gives accurate information. So what is Bayesian analysis used for? It's used in medical diagnosis. It can be used to calculate probability the patient has a disease or symptoms based on medical history. It could also be used for genetic testing to see if certain parents might have, what's the probability of having a genetic anomaly downstream. It's used in finance to make decisions in financial markets and stock exchanges. It's used in natural language processing, also machine learning, but also in engineering to do things like signal processing, control systems, and optimization. So it's used for some very serious things. It's also a really powerful technique that scientists use today. Sean Carroll is a physicist, was at Caltech, now at Hopkins. Johns Hopkins wrote a book called The Big Picture, and he devotes many chapters to Bayesian analysis and how it's become a standard tool today in science. Let's give an example of using it for, this is a legal case, and this is from a law journal, the Boston University Law Review. This is a modified form of the theory. All it's saying, this is for a criminal defendant, say a probability of guilt or innocence. And so the probability of guilt equals the initial probability of guilt times this adjusting factor probability of an event happening divided by this. The denominator has gotten bigger because I've got 2 possibilities. One, the defendant's guilty. And then the second possibility is he's not guilty. But each time there's a probability of the event associated with that. I know this sounds confusing. Bear with me. I'm going to give you an example. So the H is the sum of the events. The event could be something happened, some new, or it could be we acquired new information. As the last speaker said, history keeps updating. You keep getting new information. So if you get new information, you have to keep updating your probabilities. And this is what this allows to do. And here's an example. Let's say I have a criminal defendant who's been arrested. And he's on trial for, say, murder or some other crime. And we have 3 pieces of evidence. We have blood, we have a partial fingerprint, and we have a DNA sample. Now, a defendant in our country is entitled to a presumption of innocence, so we presume him innocent, but at a 90% level. In other words, he's going to have some probability of guilt to be arrested or to be indicted to begin with. If you start him at 0, he won't go anywhere in Bayesian analysis. You have to have some initial starting point. So in this case, we'll say 10%. For the criminal defendant, but we're still giving a pretty good presumption of innocence. So the first thing is E1. That's our first information. His blood type matched the blood at the sample. He's type O, and that occurs in 45% of the population. So given his initial probability of innocence, 0.1 by PG, then we plug into this lovely formula. Our initial probability goes 0.1, but if he's guilty, we expect the blood to match, so it's a 1. And in the denominator, that term comes down here too. But then we have to add the second term. What if he's not guilty? So he's got a 0.9 probability of not guilty, but in the case he's not guilty, there's still 45% chance his blood's going to match randomly. So that kicks his probability up to 20% from 10%, doesn't increase it a lot because it's a high probability of occurring randomly, but he's still kicked up a little bit. So now we go to the second iteration, and we're just going to say he found a partial fingerprint. There's an 80% match. So it's a 20% chance, 21% chance, again, that it matches randomly. So we bring out the last probability where we're about 20%, 0.198. If he's guilty, we expect it to match. That's 100%. And on the denominator, same form comes down here, but now we need the next term. So now he was 20% guilty. We're giving him 80% not guilty, but there's a 21% chance that happens randomly. So we run that through the formula, and now he's up to over 50%. So it's kind of looking bad for him. It's looking like he's more likely guilty than innocent. But in our system, it has to be beyond reasonable doubt. So that's not going to be good enough. So we take the last piece of evidence, which is a DNA analysis, and he matches that, except again, there's a 2% probability, 0.017, that could happen accidentally or randomly. So we have to factor that into the last equation. We bring down the 5.54 for the next iteration, bring that down, and then he's down to 4.6 probability of not guilty, and we add in 0.017. And now you see he's kicked up to 98.57. So he's almost 99% probability of guilt. And that would be enough to convict. And most people would agree that that would be beyond a reasonable doubt. And you see the probability has been adjusted, the probability of guilt, by each of the events. So by using this in an iterative fashion, you can build up and as your new knowledge comes in. All right, so now we're ready to attack the authorship problem. This problem had two possibilities, guilt and not guilt. So what we're going to do for Edward de Vere is we're going to do two possibilities. One's going to be Oxford's the author and Oxford not the author. But we have a problem. We have to find a starting point. And here comes the sticking point. What do we start Earl of Oxford out as? So the game they play, the Stratfordians play, is what do the contemporaries say? And that's all they seem to be worried about. So let's talk about what the contemporaries say. Frederick Mears was mentioned in the last talk. He's saying, okay, this guy's a great author. And this is a quote from George Putnam. In Her Majesty's time that now has sprung up among other crew of courtly makers, noble men and gentlemen of Majesty's own servants, who have written excellently well, as would appear if their doings could be found out and made public with the rest, of which first and foremost, noble gentleman, Edward, Earl of Oxford. So he's saying, okay, this guy is a great writer, but none of his plays survive. Now, he has 60 letters and correspondences that survive, 23 of his poems survive, but no plays. And he's the best writer of the Elizabethan court. Figure that out. Okay, but now the last reference is Henry Peacham's, who writes a book called The Complete Gentleman. And in that, he talks about the great poets of the age. He talks about Chaucer and other people. And then he says, in the time of our late Queen Elizabeth, which was truly a golden age, above all others who honored poesy with their pens and practice, who had a singular gift, were Edward, Earl of Oxford. So he mentions him as the #1 guy on the list. And you'll notice he also mentions Edmund Spenser, who wrote The Faerie Queene, but there is no mention of Shakespeare. And this is a very key reference. And it was really important that I mentioned in the last talk. This is not like a free speech society. You could be thrown in jail or worse, and the or worse could be pretty bad. But he's saying very clearly here, Edward Oxford is the best writer of the age. 23 poems he wrote in his youth is not going to surpass The Faerie Queene. The only guy topping this list is William Shakespeare. And he doesn't mention Shakespeare. So he's very, very clearly alluding to Oxfordian authorship of Shakespeare. And that's enough to give me a foothold. That gives me a starting point. And that starting point, I'm going to say, is 5%. So if the Stratfordians could find 20 people, 20 contemporaries, and Ben Jonson is not one of them, who say that the man from Stratford wrote the works, I've got at least one guy, a contemporary, who's saying, this is 1622, that the Earl of Oxford is Shakespeare. And that gives me a starting point. And that starting point, I'm going to say, is 5%. That's down to the noise. That's the cutoff of hypothesis testing. So I'll give Stratford, I'll start him off at 95%, and I'm only going to start him at 5%, but I do have a foothold here, which is contemporary statements that are indicating he's it. So we're going to run through the same analysis here, but this is sort of the punchline of the talk. So he starts out at 5%. And the first analysis here is he starts writing, Shakespeare starts writing 1593, Earl of Oxford stops writing 1593. So what's the probability that that happens randomly? Just like in the criminal case, what's the probability of the blood match being random? What's the odds of him just randomly start retiring at the age of 43? So there are a lot of ways to make this calculation. I finally ended up looking at the age of retirement or last writings of contemporary authors. That was something about age 48, 49. Some of them died, some of them just quit to the ill health or whatever. But the standard deviation was about 7. So it's 48 plus or minus 7. So I plug this into what's called a Gaussian calculator, and it'll give you a probability of retiring at precisely the age of 43 based on those statistics. So it's like a Gaussian shaped curve and getting in that one little slice there, and it comes out to about 7%. So it's a random probability of 7% here. So I did the same analysis, 0.05 for his authorship. If he's the author, it's 100%. But if he's not the author, Stratford guy is the author, then it's only about 7%. And you weave that in, and now it kicks him up to 43%. So one thing is a coincidence, but as we'll see. All right, so that's my first coincidence. Now our belief in the Stratford guys dipped significantly just based on that timing. That's actually very significant. Encyclopedia Britannica writes when the authorship discussion that this is a really big factor in de Vere's favor. And I think that it is. But the second one is another one. De Vere dies in 1604, in June of 1604. And there's a disruption in the plays up until that time. About 2 plays are published a year with corrections, et cetera. And then nothing appears again until 1608. So there's a multi-year 4 or 5 disruption in the play production. Now, if he's the author, fine, I expect the plays to be disrupted by the man's death. But if he's not the author, what is the probability of that happening randomly? So that's the key question. So he's writing from, say, 1593 to 1610, maybe 1612. I don't know. It's about 17, 19-year period. Assuming a break in publication occurs, the odds of it occurring at exactly that time, 1604, would be about 1 in 15. So that's another low probability event here, and you got to weave it in. So I bring down my new updated probability, 43%. If he's the author, I expect the disruption. That's a 1. If he's not the author, Stratford's now at 57%. We have to add in that 0.0066. I realize this is dry, but we're going to get to a punchline here. Now he's kicked up to 92%. So it's our belief is flipped because you've gated 2 really low probability events together. Okay, so now we're on a roll. So next, we're going to do the next one. That's the Dartmouth paper. In all 3 analytics, they took the top 3 authorship alternative candidates, Oxford, Bacon, and Marlowe. And Oxford came in first in all 3 statistical tests. Now, if Oxford is not the author, if none of these guys are the author, and the man in Stratford's the author, the odds of that happening are about 1 in 27. It's like Monty Hall had this show called Big, Deal of the Day or something. Let's make a deal. And he'd give people 3 doors, pick the big deal of the day. Imagine somebody picking the big deal of the day 3 times in a row. I mean, you think they cheated, right? Because it's only got a 1/3 probability. By the way, if you're on that game show and he shows you one of the doors and asks you to switch, always switch, because your probability of getting the right answer is only 1/3, but 2/3 of getting wrong. So if you switch, you're doubled your chances. You're now 2/3 of being right. So no one on that show ever switches if you watch it, but if you're on it, always switch. So again, the Earl of Oxford is twice as likely not to be first in any analytic, but to be first in all 3 is only a 1 in 27 probability. There's actually a wide statistical gulf between De Vere and the other candidates in that study. I'm not using any of that. I'm just saying he's the top guy in each one. So it's a low probability event, which comes out to about 3.7%. So now I have to weave that in. So Shakespeare's down to 0.08 now. We have to weave in this 0.037. We bring down the 92%. Now we're up to 99.68. So we're really hitting it. And the last thing, of course, was the dendrogram that I showed you. And I compared him to a number of other authors, but there were 8 contemporaries. So he has a 1 in 9 chance of clustering closest to the early works of Shakespeare. So that gives you a 0.111. I got to bring down my 997% and my 997 here. Again, if he's the author, I expect him to cluster close to the earliest works of Shakespeare. If he's not, then there's only a 1 in 9 chance of that happening randomly. And now we are at 0.9996. So you can see we're converging on 1 here. I haven't used any of the literary historical information. There's a ton of that. As in the first talk, you saw how much there was. All I've used is timing analytics and text mining analytics. That's it. And to get the starting point, I use a contemporary statement. There's nothing about literary historical in here. And so this is profound. And now if we look at the odds ratio, what's the odds ratio? Well, De Vere is at 0.9996. Shakespeare's at 0.0004. So he's almost 3,000 times more likely to be the author than Shakespeare. Now you're a Stratford and you say, wait, you cheated. You gave him too high a starting point. You shouldn't have started at 5%. Okay, fine. Let's start him at 1%. Any reasonable person that's not a history or English professor would give this guy a 1% start. And just the fact that multiple people will say he's the greatest writer in the Elizabeth's court, but none of his plays survive. Most reasonable people would entertain the possibility that he could be the author. So just start him at 1%. In that case, he would come up to 99.8%. And his ratio will be 500 times more likely to be the author than Shakespeare, the guy from Stratford. So in both analyses, he comes out orders of magnitude more likely. And again, I haven't used any of the literary historical factors. Now, when you're in data science, you do all your math, you do your calculations, you do your statistics, you do your analysis, and then you compare the result to the subject matter experts. What did the subject matter experts say? Well, Mark Twain says, how curious and interesting is the parallel as far as poverty of biographical details between Satan and Shakespeare. They're the best known unknown persons to ever have drawn breath on the planet. And of course, he mentions very specifically, Shakespeare is a lawyer. He's had formal legal training. Edward de Vere studied law at the Inns of Court. He also presided over trials, including Mary's Queen of Scots. He's a very strong legal background, and that's reflected in the plays. Walt Whitman used to carry a copy of the sonnets around in his pocket so he could read them all the time. And he said, conceived in the fullest heat of European feudalism by reading the plays carefully. And there are lines in there like, you shed your blood with me today, be you near so vile the spatial general condition. And there are lots of examples of that where he's looking down at anyone who's not a nobility. This is a nobleman looking down. He's writing plays for other noblemen to view, etc. He concludes that only one of the wolfish earls, so plenteous in the plays themselves, could have been the writer. Well, he's dead on accurate. Edward de Vere was an earl, was the Earl of Oxford. Notice that Twain, James Whitman are all writing before Thomas Looney. So they don't even know about Looney's identification of Earl of Oxford. They're completely in the dark. The other factor is they don't have computers in the 1900s. So they can't do the calculation that we're doing in the 21st century with the Dartmouth group and the other work. So these two things spanning a century are completely independent, but they're converging on the exact same answer. Then Henry James, a great writer, I am sort of haunted by the conviction that Divine William is the biggest and most successful fraud ever practiced on a patient world. And he said, I can't bring myself to conceive that Bacon wrote the plays as to conceive the man from Stratford as we know the man from Stratford did. So he's saying it's not Bacon and it's not Stratford. Well, our data analysis ruled out Bacon and it ruled out Stratford, the guy from Stratford. So our results converge exactly and precisely with the results of the subject matter experts from the 19th century. That's the gold standard in data science. If you can hit it that dead on, you've really got something. This gets better. All right, there was a work done by Peter Sturrock, who was an astrophysicist who got interested in this a few years ago, and he wrote a book called AKA Shakespeare, and he did a Bayesian analysis, but he didn't use any factor that I'm using. So my analysis is completely separate from his. There is no overlap of any factor in this analysis. He does look at the literary and historical factors, and he gets a result for Stratford of 10 to the negative 13. So on this chart, you're seeing it's like a decimal logarithm chart. The red indicates there's no possibility that Stratford in either of these now is the answer. So he did an analysis that was discussed in the first presentation, where you look at what evidence is there that he's a writer. The guy from Stratford has no manuscripts, no letters, no correspondences, no evidence of earning a writing table, no evidence of ever earning a book. There were no libraries in Elizabethan England. Where did he get the books? Where did he start from? Where did he read? And it goes on like that. He had no evidence of education. The people could get scholarships, like Ben Jonson came from humble beginnings and got a scholarship to the Westminster School and studied under William Camden, who was a known historian. He has no evidence of membership, absolutely nothing. So when you start to add math to that, it just drives him down into the noise. So in Sturrock's analysis, Stratford just goes down into the noise. But then the Earl of Oxford, he had the possibility that there was a third guy we don't know about. He called him McNotice. He gave him a 0.08% in one analysis, but Oxford is still 92% in this analysis. So he's same result I'm getting. He's orders of magnitude more likely than the man from Stratford. And the second analysis, Stratford just goes way down to the noise. He's 10 to the negative 27. He's converging on 0. And Oxford is converging on 1 identically. So this is the same result I'm getting. I'm topping out near 100%. Stratford's down near 0%. This is proof in science. So it's like you did a scientific experiment and someone reproduced it. So in mathematical, we've done a scientific or mathematical analysis here, and we're getting the exact same result that Oxford is orders of magnitude more likely than the man from Stratford. But we're not using any factors. There's no correlation between the two analyses. They're completely independent analyses, yet converging on the exact same result. So what are my conclusions? First is historians are not subject matter experts, as discussed in the first talk. They're often not critical enough, and they got a lot of things wrong, and this is one of them. And in this case, writers are the experts, not historians. And the great writers of the 19th century all say, the same thing. So machine learning analytics demonstrates a robust and unequivocal relationship between the writings of Edward de Vere and William Shakespeare. And Bayesian analysis is a very standard technique used today, despite what ChatGPT might tell you or whatever. It's used for a lot of various serious things like medicine, medical diagnostics, and engineering. And multiple independent Bayesian analysis of the authorship question show that Stratford is orders of magnitude less likely than Oxford to have written the works of Shakespeare. And that converges identically with the 21st century. Analytical results converge absolutely precisely with the subject matter experts from the 19th century. I think it's a tragedy that the greatest writer in history is lost to our collective consciousness. And even though he wanted it that way, if you read the sonnets, he wants to be forgotten, but we shouldn't forget him. And the second tragedy is millions of students in high school and college every year study Shakespeare without ever knowing who the author is. And you don't have the historical context to understand or appreciate the plays. And this is a tragedy. And I hope we can convince the world to take another look at this, and that English professors can go their own way. Everybody else can realize who the real guy is. I consider this matter proven, and I will be happy to debate any Stratfordian, anytime, anywhere. Thank you.